So first thing we needed to do here was what? What do we need to do first? Finding the area of this region, right? And so in order to find the area of that region, we're going to have to integrate from where to where?
The upper one minus
0
the lower
to 2.
one.
Integrate from 0 to 2, then it's going to be the upper function minus the lower function. And which one is our upper function?
It's hx is the upper, and then g of x is the lower.
H of x is our upper, and g of x is our lower. And we should be able to tell that because this looks like a cosine curve, right? And this looks more like a parabola, and this has an a value that is negative, so it should be concave down for its entire domain, whereas this is sometimes concave up. So we're going to integrate from 0 to 2, 6 minus 2 times x minus 1 squared minus negative 2 plus 3 cosine pi x over 2 dx. And I think probably best thing to do here would be to simplify that down a bit. Most likely, yeah. So 0 to 2, we got 6 minus, and then x minus 1 squared. It's going to start off with an x squared, so that's going to be 6 minus 2x squared. It's going to have a minus 2x, which should become a plus 4x. And it's going to have a plus 1, which will become a minus 2. We'll combine some more of that together in a second. This minus negative 2 should become a plus 2. And then we got a minus 3 cosine pi x over 2 dx, which finally gives us an integral from 0 to 2. We got 6. We got minus 2, and we got plus 2, so that's just going to leave us with 6. We got a minus 2x squared. We got a plus 4x. And we got a minus 3 cosine pi x over 2 dx. Everybody good with that?
Yep.
Okay. And integrating that. I guess I should have maybe given us a new page for this, but oh well, I guess we could still do that. So integrating that should give us 6x minus 2/3 x cubed. And then plus 2x squared. And then what's our integral of negative 3 cosine pi x over 2? Integral of cosine is just sine, right? But we got to multiply by the reciprocal of this pi over 2 for the u sub. So that should become a minus 6 over pi sine pi x over 2. And where were we evaluating? 0 to 2, is that right?
Yeah.
Okay. And so plugging in your 2 should give you 12 minus 16/3 plus 8. And then the sine of pi is just 0, so that's minus 0. And then all the rest of this is a bunch of zeros if I plug in 0. Everybody agree with that?
Yep.
We got 20 minus 16/3, which ought to be 60/3 minus 16/3, which would be 44/3. So a little bit of an annoying one for the area. That one was actually worth 4 points. 1 point for having the correct thing inside the integral. 1 point for correctly anti-differentiating this one. 1 point for all of the other correct antiderivatives, and 1 point for the final answer. Any questions there on part A?
Could you anti-differentiate it without distributing the x minus 1 squared? I just
Sure,
want to, because I got the wrong answer, and I just want to see if I did that right and if I get that point.
Yeah, you definitely could. You'd get 6x. This is just x minus 1, so really that's u equals x minus 1 du is dx. So it doesn't really affect anything. You'd end up with a minus 2/3 of x minus 1 to the 3 to the 3. I almost put 3 halves there, but to the third, and then minus the negative 2 would be plus 2x. And then that would be still the same thing, minus our 6 over pi sine pi x over 2. Is that what you got as your antiderivative?
No, I messed up one of the signs on something. That was all. Just like I put something as positive when it should have been negative.
Yeah, I mean, this is the, I mean, other than that, though, this is the correct derivative or correct antiderivative of this if you didn't simplify anything. Do you want me to go through and evaluate it at 0 and 2, or is that?
No, it's fine. It's fine. That's good.
Yeah, I mean, that's what you get. So, any other questions on that part A? All right, let's look at part B. So for B, region R is the base of a solid. For the solid at each x, the cross section perpendicular to the x-axis has area 1 over x plus 3. Okay, so all that's telling us then is that it doesn't tell us the shape, it just tells us that the area itself is 1 over x plus 3. And so all we need to do is take our area function and just integrate it. So for part B, we're just going to integrate 0 to 2 of 1 over x plus 3 dx. And what's the integral of 1 over x plus 3? Should be natural log absolute value x plus 3, evaluated from 0 to 2, which is natural log of 5 minus the natural log of 3, which is a good answer. Or you could have written natural log of 5/3. That would work too. 2 points for that. 1 for this and 1 for one of those. Any questions there on part B? And I know you might have a tendency to try and do something with the distance between them and multiplying that by x plus 3, but that's not, the area itself is just 1 over x plus 3. It has nothing to do with the length between them. It doesn't say anything about the length between them, right? It's not like that's a length of a side of a square or of a triangle or a radius of a circle or anything like that. So, all right, part C. Part C says we're going to take this thing and revolve it around y equals 6. And so if we want to find the volume of that, we just got to do the outer radius squared minus the inner radius squared and multiply it by pi and integrate from 0 to 2. So our outer radius should be the distance from 6 to the lower function. And like we said before, our lower function is this cosine function. So we'll say pi times an integral from 0 to 2 of 6 minus, what was it, negative 2 plus 3 cosine pi x over 2. And if you just want to write g of x or whatever that function itself was, that's fine. Minus, and then our inner radius should be 6 minus the upper function. So 6 minus this. Squared dx. 6 minus 2 times x minus 1 squared. There we go. And that's it. That's the answer to that one. 1 point for the limits and the constant. 1 point, or sorry, 2 points for having this correct. Any questions on that?
So with the 2 points for getting the correct integrand, would it break down to 1 point for the left side and like 1 point for the right side, or is it like an all or nothing thing? Like you mess up one of them, you miss both points.
It's a little unclear. It says in their scoring guide, 1 point for the form of the integrand and 1 point for the integrand. So I think they'd give you a point if you tried to do like some sort of radius something squared minus some sort of other radius something squared. So like if you did pi something squared minus something else squared, I think they'd give you one of those 2 points, even if these things inside of here were not correct. If it looked like you were making a legitimate attempt to find the radius, like if you did 6 plus instead of 6 minus, or if you did like, you know, I don't know, something else in there that was similar, like maybe you had these flipped or something, like that kind of stuff. I think they might still give you 1 point for it.
Okay.
The quiz that we take today, is that gonna be graded like on the same criteria as these questions, or?
Yeah, essentially. So
So on with like the AP style quiz we're taking today,
mhm.
like if like a 5 on the AP test transfers to like an A in the class, does that mean like if we get out like a 7 out of 9 or something like that, it's an A? Or are you gonna like grade it to where it's like 8 out of 9, that's a B?
8 out of 9, that's B.
All right.
Good news is you'll be able to retake it, I suppose. But honestly, I think I made it pretty straightforward. I think it should be pretty easy overall. And I think I would say that it is on par with the medium to lower difficulty problems that we've been doing. Anybody else have any other questions before we take the quiz?